Whole numbers are the normal counting numbers and 0. So if I were to list them out, it would be 0, 1, 2, 3, 4, and then the dot 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 just means continue the pattern. So 5, 6, 7, 8, 9, 10, and on up. Our number system is base 10. So it has 10 digits, 0 through 9. Now, decimal means 10th in Latin. That's our number system is the decimal system. But we actually use an extension of the Hindu Arabic number system that's been built up through history until we have what we have today. Many numbers like ours are positional systems or place value systems. Numbers, of course, are read left to right. And to do this correctly, we really need to know the place value of each of the digits that we have in the numbers. Of course, the digits are the 0 through 9 that I talked about before. So this table kind of shows you that spacing out and everything like that. We're going to use this table when we're going to place this number into there. And so we can start at the very end here with the 1 spot. That's where the first 2 is going to go. Then we have 1, 0, 7, 2, 4, 0, 1, 6, and 5. So of course you can see that this is going to be 5 billion is the largest place value that's shown in this number. And you can see that we have these groups of 3. It's not known specifically why we do groups of 3, but these, portions of 3 that we have help to memorize numbers that we're talking about or using them in some cases. So that's just the way it's been built up throughout history, and that's what we have today. Now, we also have commas in between each one of these groups of 3, and that's by convention of the US system. But SI system, for instance, just uses spaces. There's no commas used, just spaces in between groups of 3 numbers. Of course, this is read as 5 billion, 610 million, 427,000, and 12. You're not going to say and there, just 12 is all that you say there. So 427,012. That's all you'd say. You shouldn't use and whenever you read a number. And is reserved for the decimal point. But we're not going to be talking about those kinds of numbers right now. Okay, let's place these 2 numbers here in this chart as well. We're going to do 2, 3, 0, and 5 and a 2. So it's 25,032. And finally, the last one is going to be, I'll go ahead and just write from the top to the bottom, 4, 2, 3. It's going to be 105,243. Make sure you don't say and in there. I get tripped up when I say and sometimes. And is not a part of how you say the number. It's reserved, again, like I said, for the decimal point. Okay, now talking about very large numbers can be difficult, so we like to round to simplify what we're talking about. And when you're rounding, you want to find the place value you're talking about. Of course, each one of these is a place value, and each place value has a different magnitude of the value. So as you go more and more to the left, you're talking about larger and larger places, larger and larger values of those places. So you're going to find the place value that you want to round to. This is called the rounding digit. And you're going to look directly to the right of that rounding digit. And the digit to the right of that is called the test digit. So you're going to have the test digit. If it's 5 or greater, then you're going to increase by 1 the rounding digit. Otherwise, don't change it. Don't change the rounding digit. Finally, you're going to make the test digit and all other digits to the right 0. So it's important that you make everything to the right of it 0. You're going to kind of ignore every value that's in there. Just change it to 0, and that's how you round. You can think of it using a road analogy if that helps you. That when you're in the middle of the road, you're looking at the value to 5. So here we're rounding to the tens place. We're going to round to this place here. And the test digits is going to be 3, 5, and 6. If it's 5 or greater, you're going to round up. So you're going to add 1 to this place and then make that 0. So it's going to go up to 50. 46 is greater than 5. That 6 is greater than 5, so it's going to go up to 50. But 43 is not greater than 5. It's going to be less than that, so it's actually going to go down to 40. It's closer to 40 than it is to 50. So that's how the rounding works. Okay, let's look at that in practice here. We have 40,963, and we're going to round to the tens place. The tens place is right there. We have ones, tens, hundreds, thousands, 10,000s. So this is our rounding place for this first part. We're going to look at the next place. This is our test digit. That's not 5 or greater. So we are not going to round this up. So we have 49, 6, and then we make the test digit and everything to the right of it 0. So this is rounded to the tens place. You can see that the tens place is the last non-zero number, for whatever's written there. Everything else would be zeros. Of course, there's only one number in this case. That's rounded to the tens place. Now to the hundreds place. The hundreds place is right here at 9. So we're going to look at the number next to it. This is our test digit, 6. That is 5 or greater. So we're going to add 1 to the 9. It just so happens that 9 plus 1 is 10. That means we're going to actually roll over that 1 all the way to here. So this gives us 41,000, and that's it. This is rounded to the hundreds place, which is this digit right there. Because that was a 9, that's the reason why it got rounded up, or because you add 1 to it, it moves to the next place as well. So it's actually rounded to this place. However, it's just 41,000. Now, rounding it to the thousands place, that's going to be this place here. We're going to look at the test digit. That's 9. That is 5 or greater. So we're going to add 1 to the rounding place. And then everything else is going to be left at 0. So this one gives us 41,000. It ends up being the same number as the hundreds place, which is sometimes happens. It's because of that 9 digit. That's the only reason why. If this was 8, for instance, if this was 863, then rounding it to this place here would end up giving you 40963. Or sorry, 40900. But because of that 9 there, that's the reason why I got rounded up. Okay, finally, we're going to have round to the 10,000s place. That's going to be this place right here. The test digit is 0, so it means we're not going to round up, and rounding to the 10,000s place is just 40,000. Okay. Now, according to fiscaldata.treasury.gov, this website, you can go on there. At the end of 2022, the national debt was this very long number to the nearest dollar. And you can say this number like this, right? This is 31 trillion, 419 million, billion, 689 million, 421,559 dollars. And this number was quite unwieldy to talk about, right? We really want to round it to talk about it in any kind of context. So let's round to the nearest trillions place. That would be this place right here, right? We have 1,000, million, billion, trillion. So we're going to round to the 1 trillions place. Our test digit is the 4. That's not 5 or greater. So all of these digits are going to be made into just zeros. So we're going to get 31 trillion. And then there's the billions. There's the millions, the thousands, and the ones. So 31 trillion is rounded to the trillions place. If instead we wanted to round to the nearest 10 millions place, Well, again, we have thousands, millions. 10 millions is right here. Our test digit is 9, so we're going to round it up to 9. That's going to give us 31, that's going to be trillion, 419 billion, 690,000, or 690 million, sorry. That was billion, then million. And this is the thousand, and this is the ones. The rest of them just become 0. To the nearest billion place, that's going to be right here. So we're going to go over. Our test digit is the 6. We're going to increase that by 1 then. But of course, that means we're going to actually increase this one by 1 since it's a 9 there. That's going to be 31 trillion, 420 billion. And the rest are just going to be zeros. And that's, of course, rounded to this place. But because of the 9, that's what rounded the 10 billions place up by 1 as well. Okay, so computers can't actually store infinitely long numbers either. They also use rounding. But they tend to round, extremely far down in the decimals. That like you tend to not be able to notice where a computer is rounding. However, there are some cases which are typically these things called recursive cases where it repeats an operation over and over and over again many times. And actually where the rounding happens that it does will show in those cases. So you just have to keep that in mind. There are some cases where the rounding the computers make end up giving you an incorrect answer because it's the error in the rounding shows up. Okay, let's just review really quick. The digit 3 occupies what places here? We have the ones, then the tens. There's a 3, so the tens. Then we have the hundreds, the thousands, the 10,000s, and the 100,000s is that 3. So the tens and the 100,000s places are where the digit 3 is sitting in those 2 place values. Now, of course, we've talked about thousands, millions, billions, trillions. If you want to look up even larger numbers, you can just go to Wikipedia and look up large number names. Right here on this table, we can see that we have millions, and then billions, trillions. Then we have quadrillions, quintillions, sextillions, septillions, octillions, nonillions. It just keeps going on and on and on and up. These numbers are so large that they're hardly used in a lot of contexts. One number that is kind of nice or interesting to know is the Google, which is an extremely large number, extremely large value. That's actually where the search engine Google comes from, the name comes from.